All right, let's get started. Hello everyone, and welcome to today's webinar. For those of you new to our webinars, I'm going to let you know that audio is provided via the GoToWebinar application over the internet. So please enable your speaker, and the application has muted your microphone. Also, there's a questions tool in the application. Please use this mechanism to type any questions you have. The questions will be answered either during the webinar or in an email afterwards at the end of the day. Today we are going to do a deep dive into safety requirement specifications. I'm going to talk about what the standard has to say about the SRS and how you can implement it using exSILentia. My name is Kate Hildenbrandt. I am a product sales engineer here at exida. My role is to ensure customer success by providing training and application support for users of exSILentia and our other tools. You can see my email address at the bottom of this slide. Please feel free to contact me if you have any questions about this webinar or anything else. Just a quick overview of exida. We are a leader in functional safety tools, consulting, and assessments. We are ANSI accredited, an active member on functional safety committees, and we have global locations around the world to ensure that we are close to those who need our help. Here's a map. You can see all of our different locations. I am located in Pennsylvania in the US, a little outside Philadelphia. So I'm going to start with what does IEC 61511 say about the SRS. Then I'm going to review how you can implement the SRS using exSILentia. And then how does the SRS change after you design your safety instrument and system during SIL verification. And then we'll wrap all of this up. But first, what does IEC 61511 say about the SRS? First, it defines it as a specification containing functional requirements for your safety instrument and function and their associated safety integrity levels. So this is meant as a handoff between the analysis phase of the safety lifecycle and the design and implementation phase. So if we take a step back and look at the safety lifecycle, the SRS is meant to summarize all of the findings in the analysis phase. So once you do your process hazard analysis, your layer of protection analysis, and your SIL selection. So think of it this way. Once you identify your hazard scenarios in your PHA, and then you identify your independent protection layers meant to address the hazard scenario in your LOPA, you will have identified some safety instrumented functions. These functions will have a targeted risk reduction factor and a targeted SIL level. All of this SIF information is then summed up in a report, a Safety Requirements Specification, meant to be a handoff to whoever is designing the actual safety instrumented system. If we go back to the standard, a little more verbiage in there. The Safety Requirements Specification should be clear, precise, verifiable, maintainable, and feasible. It should be written to aid comprehension and interpretation by those who will utilize the information at any phase of the life cycle. And they should be, the requirements shall be sufficient to design the safety instrumented system, So again, this is meant as a handoff. All of the information needed to design your system should be in the SRS. But the standard goes even deeper. It goes on to list all of the requirements that would be needed in this specification. You can see in this screenshot, this is exactly the standard and what it has to say about the SRS. This is section 10. And all of those bullet points are different requirements that should be included in this report. It's a little overwhelming. There's a lot in there. And so I have made an attempt to summarize these requirements in the upcoming slides. So first we have the hardware requirements for the entire safety instrumented system. These requirements are found in section 10.3.2. They include a description of all the SIFs needed to achieve required functional safety. They include a tag list, a description of SIS process measurements, range, accuracy, and trip points, the functional relationship between inputs and outputs. So this would be a written description of what your sensor is sensing and how your final element would react to that. This includes requirements for starting up and restarting your safety system. You would want to include any interfaces between the SIS and the BPCS or operators, etc. A description of any action needed to achieve or maintain a safe state of the process, and output states to avoid. So if you have your final elements reacting to hazard scenarios, but some combination of those reactions create another hazard scenario, you want to put that in the specification. So this is a high-level look at the hardware requirements for your entire safety instrumented system. The standard also goes over software requirements in section 10.3.5. These include real-time performance parameters such as CPU capacity, network bandwidth, as well as program sequencing and time delays. It includes equipment and operator interfaces, actions to be taken on bad process variables, so if your sensor output is out of range. It includes monitoring of the logic solver, so if the logic solver is able to self-monitor, and then if it's able to monitor the sensors and the final elements. And then enabling proof testing and diagnostic testing of devices in the application program. So again, this is a high-level look. This does not encompass all of the requirements in the standard, but it is a good summary of the software requirements for the SIS. Then we can get a little more specific for each SIF. So section 10.3.2 lists the requirements for each SIF, which includes a description and the required SIL for each SIF, the SIF's failure modes and common cause failures, the definition of the safe state for that hazard scenario, the response time of the SIF, the mean repair time, maximum allowable spurious trip rate, if it's energized or de-energized to trip, the demand source and demand rates for the SIF, proof test intervals and implementation for the devices in the SIF, and many more. So that's a lot of requirements, and again, I didn't list all of them, but it's a good summary of what the standard says should be in this specification. Again, it wants you to have a clear, concise communication of all the findings from the analysis phase so that you can design your safety instrumented system. Like I said, it's a little overwhelming. How can this be achieved? Standard stages should be clear, precise, verifiable, maintainable, and feasible. So it seems a simple, repeatable work process is needed to properly document and communicate all of these requirements. The standard makes it clear what the SRS should be, but gives little guidance on how you can do this. That's where hopefully exSILentia comes in. So I'm going to go over how we have created templates that would help you to implement the SRS using the exSILentia tool. One benefit of using exSILentia to do this is that all of your analysis information from the PHA, the LOPA, SIL selection should already be in your tool. That would be in the form of our PHAX, LOPA-X, and SIL select tool. Information needed in the SRS that's already calculated or stored elsewhere in the tool is automatically transferred into the SRS. The SRS in exSILentia has two main categories, generic requirements and specific SIF requirements. The generic requirements include your purpose and scope, your hardware requirements for the SIS, software requirements for the entire SIS, and then generic SIF requirements. So even though each SIF is different, there may be certain requirements that are blanket over the whole safety instrumented system for each SIS. For instance, if you want your proof test intervals to be standard across the board, that would be your generic SIF requirements. And I'm going to go through some screenshots to show exactly how we input all of the information for these requirements. This first screenshot is your general info. You can see up top under select which section of the SRS to view, you can choose general info. That is how you get to this screen. The first thing listed is the purpose and scope. So why are we reporting all of this information? In my sample problem, I have to provide reliable protection for the plant personnel, the environment, the process equipment from reverse effects, to provide protection against spurious false trips, to minimize lost production, equipment damage, etc. So you get the idea. This would be at the top of your report once it's automatically generated, and gives a nice introduction as to why we are reporting this information in the first place. Below that, you can see the standards listed. So IEC 61508, IEC 61511, all of the standards that are applicable to this SRS and the design of your system. And finally, we have some definitions. Many of the requirements that are listed in the standard sometimes need their own definition. If a person picks up the Safety Requirements Specification and doesn't understand the difference between, mean time to repair and maximum repair time, you would want to define those here. You see here we have catastrophic overspeed and shutdown, etc. So any definitions that you think are important would be entered there. Then we move on to the hardware requirements for the entire SIS. So again, under select which section of the SRS to view, you choose SIS Logic Solver Hardware Requirements. Here you can put information in such as action on Logic Solver fault detection, action to achieve, maintain safe state when SIS is in a degraded or inoperative. The Logic Solver mean time to fill spurious, which is listed as at 20 years. The SIS output state combinations to avoid. And then it moves on to SIS interfaces with any other system. So what is your engineering station? Does it interface with the BPCS or an operator station or a historian? This information can be put in there. You can see the kind of information we put in here. At the end, you have the environmental extremes for your site, etc. What's nice about this template is it's almost a checklist. You should be recognizing some of these inputs, many of these inputs from the standard and or the summary I just gave you on the requirements. And so if you have, for instance, SIS output state combinations to avoid, we've simply put in none. But at least in the report, it shows that you have considered this. So by using this template, you have a consistent way to fill out the SRS. No matter who's doing it, no matter what your system, you will hit each of the requirements. Next, we have software requirements for the entire SIS. So you can see it has the application program information, general information, program sequencing, trip time delays, process modes of the operation. Then you have real-time performance requirements. So again, this comes straight from the standard. It mentions CPU capacity, network bandwidth, acceptable performance with faults, and specified time all trip signals are revealed. Then you have process variable validation. So what's your low detection name, your high detection name, what's your low and high range, what's your action on PV out of range, action on PV excessive, rate of change, etc. So you get the idea, but all of these things again are listed in the standard as requirements for the SRS, and you can fill in your information as needed right here. Some of it is very, very useful information. You might need to get the right people in the room, maybe a process control engineer, etc., to make sure that you have all of the required information for the design. Then in exSILentia, we move on to the general SIF information. Again, this is blanketed for all SIFs. Once this is filled in, you can, with the push of a button, simply transfer this information to each specific SIF. Now, if it doesn't apply to all SIFs, you can transfer it over and override as needed. But this helps to keep this from being a typing exercise. Hopefully it saves you some time. So we have general functional requirements, the demand mode, the operating modes, manual shutdown, protection method, trip reset, etc. You have your mission time, your major accident survivability, your mean time to fail spurious, etc. Maximum restore to service time, that's your MTTR, the restart time, startup time, etc. And then your desired proof test intervals. So again, these are things that you will need in the design phase. Some of them may change, but it is important to document them and communicate that information. So again, you can apply the general SIF information to each specific SIF, but we do have another template for specific SIF information. So this includes the SIF name, the SIF tag, what equipment is in the SIF. So here in my sample problem, we have a pressure transmitter that is opening a valve. Now, this is assumed equipment, because when you get to the design phase, you might find that to reach your required SIL level, you need redundancy. And so this is, again, a handoff of what it was concluded in the analysis phase to the designer, but it might change. So we list the process safe state, process safety time, the demand source. You'll notice here that the demand rate is grayed out. That's because it is calculated in the LOPA phase. The demand mode is low. The operating modes, the manual shutdown, etc. You see in the middle that there are set points listed with the range, the trip direction, the basis of the set point, etc. For the final elements, you have the trip action, the fail position, etc. Again, this information might have already been defined in the process hazard analysis or the layer of protection analysis, and it is automatically transferred into this template, just like the demand rate. We do have a description of the functional relationship between inputs and outputs, additional mitigation, related interlocks, etc. And then the next slide continues this SIF-specific information. You'll find at the top the required risk reduction factor and the required SIL level, and then the SIL selection method. So again, this is information that was done earlier on in exSILentia and is transferred in. So you'll see many of these are user inputs, but some of them are very important information that was determined earlier on and is transferred right in. So this will help save some time. It'll help drive consistency. You shouldn't have as many errors. We have desired proof test intervals again for the specific SIF. Again, if you want to apply that general SIF information, that's fine. But if you decide for this SIF you want a different interval, you can override that here. So you can see what this template is doing. It's listing all of the requirements for you. It's giving you a good way to automatically generate a report. Some of it's user input. You're going to need the right people in the room, as I said, but some of it is also automatically done if you've done your analysis in earlier modules of exSILentia. It is very, very easy to then generate this report. And I actually have one I'm going to show you. So exSILentia actually creates a report directly into Word. What you're seeing right now is a PDF, but I mention that because once it's generated in Word, you can change it any way you would like. So if you have some additions you want to make, you want to move some things around, that's very easy to do. It is not generated into a PDF. However, I thought this would be easier to view. So again, this is what the Safety Requirements Specification looks like. This is just my sample problem. And in the sample problem, I have only created the report for one SIF so that we can just take a look at the overall purpose of the requirement specification. We have a table of contents. It goes through the purpose and scope, the general SIS requirements, your general SIF requirements, your specific safety instrument and functions, and then at the bottom you have your abbreviations and definitions. So let's take a look. This purpose and scope should look very familiar. You saw it in the template. Provide a reliable protection for plant personnel, environment, and process equipment from adverse effects due to process upsets. Provide protection against spurious false trips, etc. So that should be familiar to you. Depending on if you want this to be the same for each SRS, or if it's project specific, you can go in there and change it yourself. Then you have some project information. The standards used are in a table at the end. So section 2 starts with your general SIS requirements. Again, this comes straight from the template, so all of this should look very, very familiar. You have your SIS interfaces to other systems, your engineering station, your BPCS, operator or historian, your major accident survivability, any startup restart requirements, and your environmental extremes for your site. And then you move on to the software requirements, which includes general program sequencing, any trip or time delays, process modes of operation, your CPU capacity, network bandwidth. Again, hopefully this looks pretty familiar. And then you can put in any user-defined requirements, which I have left blank. But you can add sections as needed. Then you have your general SIF requirements. So again, this is sort of a higher level look. What is the demand mode, the operating modes, any manual shutdown, what is the response time, the mission time, any regulatory requirements. What do you want your mean time to fail spurious to be, your sensor, logic solver, final element failure response, maximum restore to service time. There's some verbiage here on common cause failure identification, and then desired proof test intervals. And you have maintenance overrides, bypass requirements, field equipment fail-safe states. So you get the idea. Then it will move on to the specific safety instrument and functions. So there's going to initially be a large list of these functions, their required SIL and risk reduction factor, and a description. Again, I only have one SIF here, so there's only one listed. And it does break it down into low demand SIFs and higher continuous demand SIFs. And then for my SIF, you see the SIF specific information. So again, the tag name, the SIF name, the equipment, what is the process safe state, what is the process safety time, what is the demand source and demand rate, what are the operating modes, etc. And you can see the ranges, the set points, the trip direction, the unit of measurement, and then the set point basis. And for the final element, you see the trip action, the fail position, etc. There should be a written out description of the functional relationship between inputs and outputs, etc. So this should look pretty familiar. You have listed here your target safety integrity level and your risk reduction factor, required risk reduction factor, as well as the SIL selection method. You have failure requirements, mean time to fail spurious. What is your sensor, logic solver, final element failure response, maximum restore to service time, so that's your MTTR, your startup restart time, etc. And then again, each SIF specifically has its own proof test intervals and environmental requirements. So you can see how much information is contained in the safety requirement specifications. I do have some abbreviations and definitions here as well. It's a lot of information, but it's all necessary to hand off to the design teams so that they know exactly what the specification is for design. So that is the report that exSILentia generates. And that is the end of the analysis phase. However, our safety lifecycle does not end there. So one question is, how does the SRS change after SIL verification? If you're a user of exSILentia, you might have noticed that we have two different SRS reports that exSILentia generates. And this is why. The SIL verification has some impact on the SRS, obviously. So the Process SRS, which is our analysis SRS, provides a guideline for design and implementation. But while you're defining the conceptual SIF design, some information from the Process SRS may need to be updated. So we have desired proof test intervals, but if our desired proof test intervals, once put into the calculation, don't help us to achieve our target safety integrity level, they might need to be adjusted. The relationship between inputs and outputs might also need to be adjusted. There might be a need for redundancy. So again, in my sample problem, I had one pressure transmitter that opened one valve. However, if that architecture does not reach the required safety integrity level, then you might need to add to it. As well as SIF level diagnostics, your mission time, your mean time to restore. All of these things change the calculation, and during the design it might change, and so you need a place to document that. Also, once your equipment is specified, additional implementation requirements might also result from the design phase. So that includes any equipment-specific environmental restrictions and mandatory maintenance activities. These will obviously become clear when you choose your actual piece of equipment from a certain manufacturer with a certain model number. You might find there are additional requirements associated with that piece of equipment. I wanted to walk you through quickly what SIL verification looks like in exSILentia to give you an idea of what I mean. So you see here, this is where we specify the sensor. You can see we've chosen a manufacturer, a certain model number, pressure transmitter. You can also see a proof test interval is defined and a proof test coverage, as well as a mean time to restore. The sensor classifications are input here, and this goes into the calculation for the overall achieved SIL level. We have a similar screen for the logic solver. Again, the MTTR, you'll see proof test interval, proof test coverage, and your equipment selection. And finally, we have the final element. This has all the same things. So your proof test interval, MTTR, proof test coverage, and your specific equipment, as well as any classifications. So the point of design is to figure out exactly what architecture equipment you're using, as well as make sure that you achieve your target safety integrity level, your target risk reduction factor, and your target mean time to fail spurious. If your desired proof test intervals, your desired mission time, your desired MTTR, do not reach those requirements, then they might have to change, and you might have to document that somewhere. So here's your overall results. Like I mentioned, up top, well, at the bottom section, you have your achieved safety integrity level, your risk reduction factor, and your calculated mean time to fail spurious. So how should these changes be documented? This is tough because since the Process SRS is sometimes a contractual document, you might not want to change it. It might not be easy to make changes to it. So what exSILentia does is it allows users to define a Design SRS, which combines the Process SRS requirements with your conceptual design requirements to provide a single source of information for the detailed design engineers. This becomes a handoff between design and implementation. So what has been specified is properly documented and communicated. I'm going to go back to our safety lifecycle overview. Here you see the Design SRS. After SIL verification, after some lifecycle cost estimating, you're going to have a conceptual design that also needs to be communicated. So what does this look like in exSILentia? The template is very similar to the regular SRS, and so I'm not going to go through that, but I can show you what the report looks like. Again, some of the information from the design is going to be automatically transferred into this report, and then much of it is going to be user-defined. So let's scroll up to the top. You have your table of contents. This should look pretty familiar. Project purpose and scope. You have your general project information, what standards you used, general SIS requirements, general SIF requirements. You can see all the information there. Spurious trip rate, mode of operation, protection mode, mission time, response time, etc. And then it dives into each SIF specifically. So you see my sample project SIF there, SIF 501. Again, I only generated a report with one SIF for simplicity's sake. So let's get into it. You have your purpose and scope, your project information, what standards were used. You see IEC 61511, IEC 61508. Have some definitions, and then you have your general SIS requirements. You have environmental conditions, etc. The next section goes into general SIF requirements. You can see all the information that is put into here. You have operating modes, trip reset, mission time, response time, your test intervals. You have some verbiage on common cause sources, failure modes, any diagnostics, and then we dive into the SIF specific information. So again, there's going to be a probably large SIF list. Again, I only have one here, but you would have a large list that would list the tag names, the SIF name, and the SIF description, as well as a revision. So if you've made any changes to the design, you can list that revision there. Then we have the functional relationship between the inputs and outputs. We have a description there. Again, this is a pressure transmitter that will open a final element. And then we have a cause and effect matrix for each SIF. So here you see my PT501. You can list a cause here. This will be, again, a written out description. You have a type. You have the range, the action, high trip, the set point, and the engineering units. This shows that it's going to open XV500. Again, you can put the effect in here. This is going to be a written description of the effect. So that would be a cause and effect matrix simply for one SIF. It's very straightforward. Sometimes they get a little more complex, a little more exciting. And you have SIF sensor part requirements. So what's the sensor group name? What's the response time? The mean time to restore? The proof test interval? Proof test coverage? Again, these are results from the design calculation, so these are now set in stone. You have process connections, start requirements, restart requirements, survivability, etc. You have a P&ID listed for reference. And then you move on to the logic solver. You're going to see a lot of the same information here. But now that you have chosen the equipment for each part of the SIF, you can get into this detailed specification. Finally, we have the final element group. Again, a name, a response time, MTTR, proof test interval, diagnostics, your process connections, etc. You can see there's some description here, components within the drain to quench tank. That is all project specific information. And then you have a P&ID for reference. So you can see all of the information. It's very similar to the Process SRS, but it's after the calculation, it's after the design. It's specific to the safety instrumented system that you are going to implement at your site. So that is the Design SRS in a nutshell. One thing I want to show you, another output of exSILentia is the cause and effect matrix. I showed you in the Design SRS, you saw it for one SIF. However, it does produce a complete project cause and effect matrix. You can see on the left-hand side, the sensors are grouped according to their logic solver. So everything that's attributed to that logic solver is grouped together. You have, again, your tag names, your causes, your type, your ranges, your set points, your engineering units. Then it shows exactly the relationship to the final elements. You see some of them are reused, and some of them just have a very simple input to output relationship. So that's a nice high-level look at the entire safety instrumented system. This is automatically generated from exSILentia once you complete your conceptual design. And the standard does mention having a cause and effect matrix or an overall description of the SIFs and their inputs and outputs. So this is a nice way to do that. You can, as I said, put in a description, a written description into the cause and effect matrix as well. So let's summarize all of this. In exSILentia, the Process SRS summarizes findings from the analysis phase of the life cycle. So that's your PHA, your LOPA, and your SIL selection. This provides a guideline for the design of the safety instrumented system. After conceptual design is complete, the Design SRS adds information gathered during the conceptual design. So once you've determined your SIF architecture, your equipment, this will validate or change the initial SRS requirements. And instead of rewriting or having a new revision to what could be a contractual document, you now have a second document that has all of the information combined. So exSILentia strives to simplify this process by transferring information from the analysis and design phases directly into the SRS templates. And like I said, the template also acts as sort of a checklist. You can go through and make sure that you've considered all of the requirements that the standard wants you to consider, to document, and to communicate. However, if this task still seems overwhelming, exida does offer consulting services and on-the-job training for creation of the SRS reports. So this can be done in in conjunction, with exSILentia, so we can help you learn to do it so that you can eventually do it yourself using the tool. Or this can be done if you'd rather us just take care of it as a consulting service. And if you want to learn more, we do have some upcoming classes. These are not SRS specific, but you can see through April, May, and June, we have our FSE 100, FSE 110, FSE 211, CS 201 courses. Many of them are in Sellersville, so you can come and visit us. We have one in England, and we do have our FSE 100 course online, which is hopefully very accessible to everyone. That's pretty exciting. So please check out our full training schedule. You can see the URL right there. exida is also on Twitter. And if you have a suggestion for a webinar topic, please let us know. We like to add value. We like to answer questions and be helpful. And so send your suggestions to academy@exida.com. So that wraps up Process and Design Safety Requirements Specifications implementation in exSILentia. Take a look here. So someone asked, what is the output from exSILentia for the SRS? Is it a report per SIF or a complete report for the whole safety instrumented system? Again, my sample project was just one SIF, so this might have been unclear, but it does both. It tells you all of the requirements for your complete safety instrumented system, and it dives into any SIF-specific information. So all of your SIFs will be listed. All of the specific information for each will be listed. So it's everything in one report. It should be one handoff that you have to make to the design team, and then eventually from the design team to the implementation team. And that is the only question. So I am going to wrap this up. We will be sending out the slides as well as an answer to any question. We had questions from the earlier session. So we want everybody to benefit from that information. We'll send out a list of questions and answers. But thank you so much for listening in. I hope you have a good day. Bye.